Very good evening, students. Today, I'm going to discuss regarding some laboratory assignments on numerical programming, rather numerical methods programming. Let me share the screen with you. Assignment number 7. In assignment number 7, we have this following assignments like this. I'm sharing the screen with you. I hope the screen is visible to you. That is the first part of the program, rather 7A. It is the program on numerical integration. Fine. That means function is given, fx is given, integration 0 to 1 dx 1 by x square, 1 by 1 plus x square is my function dx. And we have to use this following methods, any one of the following methods, better to say, because all are given in a form of slash. It's a trapezoidal rule, Simpson's one-third rule, Wedley's rule, Euler's theorem, any one of this to evaluate following functions, fx, dx. Fx is in this case, it is 1 by 1 plus x square. And the second problem, that is finding root by using any one of this method. It's a regular Fulci method or Newton-Raphson method of the equation x cube minus 3x minus 5 equal to 0 up to 3 decimal, correct up to 3 decimal places. So these are the two programs given in assignment number 7. So let me introduce the theoretical concept of this numerical methods problem in brief. Then after I will enter into the programming implementations of this theorems. So what is the meaning of this numerical integration? The meaning of this numerical integration is the area bounded by curve fx and the area bounded by curve fx and x-axis between limit a and b. Between the limit a and b is denoted by fx dx, limits a to b, integrations a to b, fx dx. So the meaning of this is this: the curve, the area better to say, bounded by a curve fx and x-axis. So the pictorial representation is just like this. Fine. This is the function. This is the function y equal to fx and the curve, the area bounded by this curve and the x-axis. That means this much of area. And it is given from where to where? The range is, the interval, the range is from A to B. Fine. Range is from A to B. And in this type of problem, when I'm going to find the numerical integration, that is denoted as capital I, the interval is given. When I discussed about the problem statement of this assignment, look, n equal to 24 is given. So n is, here n is nothing but a interval. Fine. So we have to divide this interval from A to B into n equal interval. We divide the interval A to B, that is the range, entire range from starts from A and ends till up to B. So I have to divide the interval into n equal intervals, and each interval length is denoted as small h, which is called step size. Again, I'm repeating, I'm dividing the entire interval. My interval starts from a, lower limit is a, upper limit is b, into n equal intervals. N is given in the problem. So definitely n interval, rather each interval have a length h, and that is called the step size. That is called the step size. So if I go through it, if I try to pictorial represent it, then it will be look like this: a to b, n intervals. So a equal to x0, x1, x2, x3, x4, xn minus 1, and xn. Xn is basically b, because it's the upper limit, upper value. Its range is from a to b, right? So how we can denote this age? Age, definitely the age value will be b minus a by n. I hope this much is clear to you. So if your a equal to x0, then definitely your x1 will be x0 plus h, x2 will be x1 plus h, and similarly your xn will be xn minus 1 plus h. So this thing I just represented over here. Each and every interval is, the length of the interval is equal, and that is the value of the interval is h. And if I try to evaluate the value of n, so n will be b minus a by h. That is coming from here. So we have n number of theorems to find the value of this I. So I will discuss one or two, and I will implement any one as per assignment. I will implement this, any one of this list of theorem given. So try to understand the theorem first. So first theorem I am going to discuss is trapezoidal rule. So I already know what is the meaning of this integration ab fx dx. What is the meaning of this? That I already represent to you in the pictorial format. And when I know the value of x0, definitely I can get the value of y0, because y equal to function fx. So x0 corresponding value is y0, x1 corresponding value is y1, x2 corresponding value is y2, x3 corresponding y value is y3. In this way we can calculate the corresponding value of y. Fine. So the formula, rather the theorem of the trapezoidal rule is this: h into y0 plus yn by 2. That means first value plus last value by 2 plus all the remaining values, y1 plus y2 plus y3 plus y4 plus yn minus 1. And it is applicable on any number of interval. No constraint here, no constraint is here for the number of interval in case of trapezoidal rule. Again, I am repeating the formula. The formula is h equal to y0 plus y1 by 2. That is first value plus last value. What is y0? What is y1? What is y2? What is yn? This much I already discussed with you just before coming to this theorem. So the formula says y0 plus yn by 2, then y1, the rest of the terms will be added with this. Another formula I'm going to discuss over here, that is Simpson 1/3 rule. What is the Simpson 1/3 rule? The condition given for Simpson 1/3 rule is the number of intervals should be even. The number of intervals should be even. That is the constraint on the interval for the Simpson one-third rule has. The number of intervals should be even. The formula is h by 3, y0 plus y1, first value plus last value. Fine. Then the remaining y values will be split into two parts, better to say. What are the two parts? One are the odd terms, another one the even terms. Odd terms will be added and multiplied by 4, and even terms will be added and multiplied by 2. Fine. I hope you understood. Again, I am repeating the formula. This is the theorem. H by 3, y0 plus yn, first term plus last term, plus 4 into odd terms, y1 plus y3 plus y5 plus y7 in this way, and 2 into the even terms, y2 plus y4 plus y6 plus y8 in this way. Fine. And it is applicable only when, keep it in mind, it is applicable only when the total number of interval is even. This is the Simpson one-third rule. That is the theorem. And yes, Simpson, there are one more rule which is not given in our assignment. That is Simpson 3/8 rule. What is Simpson 3/8 rule? Simpson 3/8 rule will be just like this. 3h by 8. Try to understand the formula. 3h by 8, y0 plus y1 plus 3 into, before coming to this term, first check this term, 2 into multiple terms of 3, multiple of 3 terms, matlab y3, y6, y9, y12, in this way it will be added and it will be multiplied by 2. And in case of middle term, that is 3 into, that is the remaining terms. Remaining terms means except y0, y1, yn and multiple terms of 3, except this, all are will be in the multiply of 3, in the multiplication of 3 will be added, and finally the result will be evaluated. Fine. One more constraint over here is, it is applicable if total number of interval is multiple of 3. It is applicable if total number of interval is multiple of 3. I hope you understood this much. These 3 theorems I discussed. One is trapezoidal, second one is Simpson one-third rule, and the third one is Simpson 3/8 rule. Now I am coming to the trapezoidal rule in detail. I already discussed about the theorem part. That is what is the formula to calculate the value of this h by 2, y0 plus y1, yn, 2 into y1 plus y2 plus dot 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 plus yn minus 1. So if I try to write an algorithm for this trapezoidal rule, what we have to do? We have to input n. What is your n? That is your number of interval. Fine. Definitely your second step is in input. You must have to input the lower limit and the upper limit. Fine. That is a and b. And you have to calculate the h. We already know how to calculate h. H equal to b minus a by n. N is the number of interval which is already given. And in case of trapezoidal rule, you already aware about that number of intervals can be any number. It must be finite, but can be of any number. So there is no constraint regarding the number of intervals in case of trapezoidal rule. Very nice. So the x0 equal to a, definitely the first value is x0 equal to a, x1 will be a plus h, x2 will be a plus 2h, similarly x3 will be a plus 3h, because the interval value of each x points, each x interval, the length difference is h, that we already discussed. Now we have to calculate y. How we can calculate y? By the value of fx, by the formula given in fx, function given in fx, better to say, function given by fx. So I have to calculate y0, y1, y2, yn. Then I have to put that y0, y1, y2, yn in this formula, in this theorem, and finally we can get the result. So let's try to do a mathematical problem. Fine. Suppose fx is given x square plus 2x. X square plus 2x is the function given. Fine. And the lower limit is 1, upper limit is 4. Try to understand. Lower limit is 1, upper limit is 4. What is your n value? 6 given. Considering 6. So what will be your h? Definitely 4 is your upper limit. Minus 1 lower by 6 will be 0.5. Fine. Now you have to calculate what? How many intervals we have? 6. So we have 6 intervals starting from 1. Second one will be 1.5. Third one will be 2. Fourth one will be 2.5. Fifth one will be 3. Sixth one will be, sorry. 1, it starts from 1, that is your x0. x1 is 1.5, x2 is 2, x3 is how much? 2.5, x4 how much? 3, x5 3.5, and that is your x6 4. I hope you understood this much. Fine. Now you have to calculate the corresponding y terms, that is your y0 to y6, putting value of this x and the function fx. Here fx is x square plus 2x. So if you put the value of 1 over here, so how much you will get? 1 square plus 2 into 1, that is 3. If you put 1.5 in place of x, you will get 5.25. If you put 2 over here, you will get 8. So in this way, we are calculating y0, y1, y2, y3, y4, y5, y6. It's very simple. Nothing complex here. Next, what to do? We have to put the value of y0 up to yn in the formula. What the formula? Try to remember. It is h by 2. Fine. H by 2. y0 plus yn. So h is your 0.5 by 2. y0 is 3 and y0 is 3 and your yn is how much? 24. And rest of the terms will be multiplied by 2. 2 into y1, y2, y3, yn minus 1. So 5.25 plus 8 plus 11.25 plus 15 plus 19.25. These are the remaining terms. So if you calculate this value, you will get the answer 36.125. That is your result. Fine. Moving to the next formula, next theorem, that is Simpson's 1/3 rule, already discussed with you. In the same manner, in case of trapezoidal rule, in the same manner we have to take input n, but in case of Simpson's 1/3 rule, the number of intervals should be even. The number of intervals should be even. Fine. Then calculate h. The formula of h we all know. First we have to take the input of b and a. Then I have to calculate the value of h. H equal to b minus a by n. Fine. What is your step 3? Just like before, just like previous, x0 equal to a, x1 equal to a plus h, x2 equal to a plus 2h, xn equal to b. What b means? That is a plus nh. What is your step 4? You have to calculate y0 to yn by the functions given fx. And what is your step 5? You have to evaluate the value, rather you have to use the value of y0 to yn in the formula, in the theorem, to get the final result. What is the theorem? H by 3, y0 plus yn, 4 into all odd terms plus 2 into all even terms. That you already discussed earlier. Now try to evaluate a problem with this. So the function given x by 1 plus x. Fine. And the interval given, that is n equal to 6. So how much your h will be? H will be 1 minus 0 by 6. H will be 1 minus 0 by 6, that is 1 by 6. Fine. So now next step is we have to calculate the value of y, y0, y1 up to yn. So x0, y0 will be 0. Fine. 1 by 6. If I put the value of x equal to 1 by 6, so how much we get? 1 by 7 over here. Similarly, next value will be 2 by 6 because interval, the value of h is 1 by 6. So if x0 is 0, 0 plus 1 by 6, so x1 value will be 1 by 6. What will be the value of x2? 1 by 6 plus 1 by 6. So it will be 2 by 6. What will be the value of x3? 2 by 6 plus 1 by 6, again 3 by 6. In this way we can calculate x0 to xx, x0, x1, x2, x3, x4, x5, x6. And try to find the value of y0, y1, y2, y3, y4, y5, y6. When the value of x0 is 0, the corresponding y0 value is also 0. If I put the value of x as 1 by 6, we'll get the value of y. The y value will be 1 by 7, right now, by using the function fx, x by 1 plus x. So in this manner, we can calculate y0, y1, y2, y3, y4, y5 up to y6. I hope this much is clear to you. Next part is, I have to use those values in this theorem. What is the theorem says? H by n. So 1 by 6, h is your 1 by 6. Fine. How much your h? H is 1 by 6. Sorry, h by 3. So h is your 1 by 6. If h is 1 by 6, so h by 3. So 1 by 3 into 6. Next part is y0 plus yn. Right? Next part is y0 plus yn. Y0 plus yn. 4 into odd terms plus 2 into even terms. So y0 plus yn. Y0 is 0. Yn is 6 by 12. Y0, yn. Fine. 4 into odd terms means y1, 1 by 7, y3, 3 by 9, and y5, that is 5 by 11. 2 into even terms, that is y2. Y2 is how much it will be? How much it will be? It will be 2 by y2, 2 into even terms. Y2 will be 2 by 8 probably. Let me check once again. If your x value is 2 by 6, 2 by 6 by 1 plus 2 by 6. 2 by 6, 1 plus 2 by 6. So definitely it will be 2 by 8. It is right. So done a mistake over here. So value will be 2 by 8. Fine. So 2 by 8 and then another value is 4 by 10. So if you calculate this, you will get a result something like this. Maybe different because I put the value 2 by 7, it will be 2 by 8. Fine. So check once whether the value is 3.0 means this much, 0.30683 or something else. Put the value 2 by 8 over here, not 2 by 7. And once again calculate it and check the final result. So I hope you understood this much. Now I move to the programming implementation. I move to the programming implementation of these two methods. One is trapezoidal rule, another one is Simpson's 1/3. So what is the function I have to consider over here? Look the function, look the assignment. The function is 1 by 1 plus x square and the limit starts from 0 to 1. Fine. And my n is 24. I'm using trapezoidal rule, and later on I will use Simpson 1/3 rule. This two I will implement. Fine. So first one is the trapezoidal rule. In the trapezoidal rule, we have this n value is 24. That means number of interval is 24. And the function given, fx given 1 by 1 plus x square dx. And the result is 0.7854. So try to understand the code that I have written. So I have considering a function which is basically calculating the value of y0, rather y0, y1 up to yn. So that's why I am defining the function fx 1 by 1 plus x square. So this float f function is basically calculating the value of 1 by 1 plus x square. If you put the value of x, your function will return you the value of corresponding y. Fine. So float f, this function actually calculating the value of 1 by 1 plus x square. That function is given in our assignment. Next part of my problem, try to remember the steps. First, we have to take the input lower limit, upper limit, and number of intervals. Then we have to calculate the value of h. Very simple it is. A, it's a lower limit, B is the upper limit, and number of intervals. Then I have to calculate sum. What this sum, initially what, try to remember the formula. The formula is, in case of trapezoidal rule, the formula is y0 plus yn h by 2, the last part. Try to remember the inner part of this function, or rather theorem. y0 plus yn plus 2 into rest of the terms. So in case of initial step, what I'm doing, I'm calculating the y0 and yn. This is my f of a. When I'm writing f of a means the lower value, the interval's lower value, and b is the upper value. So when I'm writing f of a, what it returns? It returns corresponding y0. It is basically a is my x0 and b is my xn. So when I'm writing f of a, that means it gives us y0 and f of b gives us yn. So what I'm doing first, y0 plus yn, done. Then what I have to do, the remaining terms will be added after multiplied by 2. So that means this formula says 2y1, 2y2, 2y3, 2y4, 2 into yn minus 1. That is the part. So this thing I have implemented in the for loop. I have implemented. So a plus I into h. H I already calculated. What is the meaning of a? First value. I starts from 1 to n minus 1. Why it is 1 to n minus 1? Because if the number of interval is 6, so I have to consider from x0 to x6, right now. Just I have shown you the previous implementation, rather mathematical problem, I have to, if the n value is 6, I have to consider the value of x from x0 to x6. And your remaining parts definitely lies between first part is y0 plus yn, and the remaining terms means y1 to yn minus 1. So that's why I iterates from 1 to n minus 1. Very nice. Then if I write it inside braces, it will be very much clear to you. H I already calculated. So if I multiply I with H and that is added to A, that means I am calculating the interval value. Y1, Y2, Y3, Y4, this way. And each interval, each Y value is multiplied with 2. How we can get the Y value? We are calculating the X, new X, X0 and X1. How much difference between this? Plus H. So when I am writing 1 plus 1 into H, that means this is the value H will be added to X0 and I am getting X1. And if the same X1, if I pass it as a function parameter of F, so definitely what I will get? Y0. Sorry, Y1. When the I value is 2, actually this X becomes X2. And when I am passing this X2 over here inside F as a parameter, Fx will return us Y2. When the X value is 3, so 3 into H, A plus 3 into H, how much it is? It is basically X3. It is basically X3. And when I'm passing this X3 as a parameter of F, function F, so it will return us Y3. And that must be multiplied by 2 as per theorem. So finally, and after multiplied by 2, it will be added to the value, added to the variable sum. I hope this much you understood. So how far we have done? We have done this much. Y0 plus yn, this is the outer part of the loop I have done first. Then we calculated y1, y2, yn minus 1. Initially I calculated x1, x2, xn minus 1. I have passed the x1, x2, xn minus 1 in the function f. And then I multiplied 2 of that result and added to the variable sum. So finally the sum variable gives us this much. Fine. So what we have to do next? Next we have to multiply h with the sum, and I have to divide it by 2. So that thing I have done after coming out from the loop. I have to multiply h with the sum and divide it by 2 to get the result I. So I will be our final result. So if I execute the program as per the problem definition, our upper limit is 1, lower limit is 0, and interval is 24. So lower limit 0, upper limit 1, number of sub intervals is 24. So results giving 0.785326. Results already given in the assignment. Yes, 0.7854. So 0.7853 it is giving. It's almost nearer. Fine. So I hope you understood the implementation of this trapezoidal rule. Next, I am going to implement the Simpson 1/3 rule. Try to remember the formula of this, rather theorem of the Simpson 1/3 rule. H by 3, y0 plus yn, 4 into odd terms plus 2 into even terms. So like trapezoidal rule, we have to define the function. I'm keeping the function unchanged because the function is 1 upon 1 by x, 1 plus x square. So that function actually gives us y value, corresponding y value if we pass the value of x as a parameter to the function. Fine. So like similar, like previous program, I have to take lower limit, upper limit, number of intervals, calculate age, then calculate sum. This much is remain unchanged with the trapezoidal program. Fine. Next part is I have to check whether the number is even. The loop also iterate 1 to n minus 1. That part also remains same as previous. Then what I have to check? I have to check the value of I is even or odd. If the value of I is even, then I have to multiply the value with 2. If the value of I is odd, I have to multiply the y value with 4. That is the difference with the previous program. And ultimately the summation value will be multiplied by age and will be divided by 3. That is the theorem says. So I will just do that thing. First, I have calculated the corresponding x value by using this formula, same formula, a plus I into h. So if I value is 1, that means I am calculating x1. If I value is 2, I am calculating x2. If I value is 3, I am calculating x3. When I am passing x1, x2, x3 as a parameter of f, that means this fx will give us corresponding y, y1, y2, y3, this much. I'm adding that a and that value with, I'm adding that value with the sum by either multiplied by 2 or multiplied by 4. That depends upon the terms, whether it is even or if it is odd. If it is even, it will be multiplied by 2 and will be added with sum. If it is an odd, so it will be multiplied by 4 and added with the sum. So I hope this much is clear. And after coming out from the loop, what I have to do, h by 3. Formula says h into this much, h by 3 and the rest of the part. Rest of the part we have already calculated in the for loop. So after coming out from the for loop, we have to multiply the sum with h and divide by 3. So that's why I have done this. I have written this line, h into sum by 3, and definitely the result will give us by the variable I. 0.4 is given, %0.4. So after 4 decimal places, the result will be printed at the output. So let me check the output of this program. Fine. So lower limit as per problem definition, again, let me check the problem definition. Lower limit 0, upper limit 1, and number of intervals 24. So after 4 decimal places, if I print, the result becomes 0.7854, which is same given as the answer of your assignment. So I hope this much is clear to you. So it is discussed assignment 7A, 2 methods we implemented. One is trapezoidal, another one is Simpson 1/3. Now moving back to the theoretical part once again for the second problem, where I have to find the root by using any of these 2 methods, regular falsi or Newton-Raphson. So find the real root of this equation, x cube minus 3x minus 5. So we will discuss the second method only, that is Newton-Raphson, and I will try to implement this Newton-Raphson method in our programming. So try to understand how Newton-Raphson method works. So this is the function fx given, rather the equation fx given. And this is the root of this equation. This point is basically the roots of the equation at x-axis. And we have to find this particular root. Fine. We have to find this particular root of this equation given. Fine. So equation given as fx, right? What are the steps? The steps are: consider the equation fx equal to 0. If initial value is not given, then use intermediate value theorem. What is intermediate value theorem? Intermediate value theorem is you have to find the range. You have to find the range of the value of this for this function fx where your root lies. Where your root lies. Again, I am repeating. First step is consider the equation fx equal to 0. That is already considered. Second step is, if your initial value is not given, that means from where you try to search your root. Whether you start from 0 or whether you start from 1 or whether you start from 2 or whether you start from 3. Suppose your root value is 2 point something. That means your root lies between 2 and 3. So that's intermediate value theorem is basically tells us the range from where to where your root lies. And you have to use this intermediate value theorem. And the theorem is like this. The A and B, you have to find such A and B where fa is less than 0, function given, fx is already given. If you put the value of A, you will get the value less than 0. And if you evaluate the function for the value of B, you will get the value if B is greater than 0. That means something positive value. And when you are putting the value A, you are getting some negative value. So your range is A and B. That means within this range, your root lies. Your root lies between the value A and B. This means this. Fine. So your initial value will be either A or B. Anyone you may consider. Anyone you may consider. Fine. So after considering this, I am finding, after considering either A or B, I am finding f of x0. That I already calculated. F of A, better to say, or f of B. Both are calculated. So f of x0. At the same time, I also calculate f dash of x0. F dash of x0. That's the derivative of this fx. Fine. F dash of x0. Then the formula, first approximate root by Newton-Raphson method, that is your xn, x1. x0 I initialized either value A or value B. Next I am going to calculate value x1. Next second iteration I will calculate value x2. Third iteration I will calculate the value x3. This way I will go on. How many times I will move? I am coming to that point later, just after this. So try to understand the formula. The formula is, when I am calculating x1, the formula is x0 minus fx of 0 and f dash of x0. Fine. After calculation of the first root, that is x1, approximate root by Newton-Raphson, that is x1, then I have to calculate fx1 and f dash x1. And I have to use this fx1 and f dash x1 for calculation of x2, because x2 is, the formula of x2 is remains same. Just look at the previous. When I'm calculating x1, I have to use x0, f of x0, f dash of x0. When I'm calculating x2, I have to write x1 minus f of x1 by f dash of x1. Hope this much is clear to you. Similarly, when we calculate x3, the next step will be, we have to find f of x2 and f dash of x2. And the third approximation root, that is x3, will be x2 minus f of x2 by f dash of x2. So if I generalized it, the formula will be x of xn plus 1 will be x of n minus f of xn by f dash of xn. So I hope you understood this formula. Now I am moving to a problem, rather a mathematical problem. Suppose your problem is find a Newton-Raphson method, using Newton-Raphson method, find the real root of the equation x cube minus 2x minus 5 equal to 0. That is your fx. So fx set to be 0. So x cube minus 2x minus 5. So no initial value given. So I have to use this method, that is intermediate value theorem method, to find the range of the root. Fine. So how we can use this? Starting from 0, if I put the 0 in place of x, the f0 will be minus 5. f1 will be minus 6. f2 is minus 1. f3 is 16. I will stop over here. Why? Because I discussed the intermediate value theorem says the a and b will be such that f of a is less than 0 and f of b will be greater than 0. So if we get one minus and one negative and one positive value consecutively, we have to stop over there. So here is the case. I start from 0. f0 I am getting minus. f1 I am getting minus. So I will not stop over here. f2 again I am getting minus, negative value minus 1. So I will not stop over here. When I am getting a positive value, 16. So one value is f2 which is negative, and second, so two consecutive value, one is negative, another one is positive. So I will stop over there. And I conclude the root lies between 2 and 3. The root lies between 2 and 3. Using this intermediate value theorem, we have find this. Next part. I initialized x0 with 2, that is this value. I may initialize the value with 3 also. No problem. Fine. What is the first approximation formula? First iteration or first approximation? First root x1. So x1, the formula, try to remember the formula, x0 minus f of x0, f dash of x0. So what is your fx? Your fx is x cube minus 2x minus 5. So definitely your f dash x will be 3x square minus 2. So put the value of x over here. So fx, fx1, sorry, there's a second approximation. So fx0 is minus 1, f dash x0 is 10. So I put this value and I'm getting x1 with the value 2.1. Second approximation, I have to calculate fx1, which I'm getting 0.061, and f dash x1 I'm getting 11.23. I hope you understood this much. There's nothing but the calculation part that I have not discussed in detail. So next I have to use the formula for x2, finding x2. The x2 formula is x1, f of x1, f dash of x1. So putting the value 0.0x1 and 11.23 will give us 2.0946 rounded to up to 4 digit. So next question, how many times it will iterate? When we get two consecutive iteration, rather two consecutive approximation result is same, almost same. two consecutive approximation result is almost same, we will not find furthermore, and that is the root value. I considered that will be the root value. So again, I am here. First approximation value was 2.1. Second approximation value is 2.0946. Almost similar, but not same. If I rounded it to one digit, it is almost similar, but it is not same. Fine. So that's why what I am doing, I am moving further. So third approximation, what I have to find, f of x2 and f dash of x2. F of x2 is this, and f dash of x2 is this. Using f of x2 and f dash of x2 and x2 value, I am calculating the value of x3, which is 2.0946. Remain unchanged. Second approximation value of x2 is 2.0946. Third approximation 2.0946 remain unchanged. So I consider I have to stop over here. I will not move further, and I consider the root of the equation will be 2.0945 or 2.0946. So I hope you understood the theoretical concept of this Newton-Raphson method. Now I'm trying to implement. I try to implement the Newton-Raphson method. The function that given to us is what the function? X cube minus 3x minus 5. So this is my fx. So I have written two functions. One is fx, another one is delta of fx, df. Fine. This is the derivative of f. So what is the derivative? If the x cube minus 3x minus 5. So that means 3x square minus 3 will be the derivative. So this is my df. So I hope you understood this much. Then I have taken the desired accuracy. I'm coming later what this is required. Then the value of initial root and desired root. Sorry, initial value of the desired root, x0. I hope x0 is given to you. Fine. So intermediate theorem calculations I have not used in the programming. I hope we have the initial value, and we have to put the initial value as an input of this program. Next part what I am doing. A equal to x. What is my x? That is my initial value. Fine. So I am calculating x1. This is my x0. So when I am calculating x1, so this is my x0. A is my x0. Fine. A is my x0 minus f of a, f of x0 by del f of x0. That actually gives us x1. Fine. A is my x0. Try to understand. I am updating x. So I am updating x. So that's why I am backing up this x value inside A. Because x1, x2, x3, x1 is now updating x0 as per the coding part. So as because x is updating, so I'm putting the previous x value inside A. I'm used this f of A. What is the meaning of f of A? That is f of x0. Here x is f. Initial x is x0. So f of x0 by del f of x0, x0 minus. So that is actually x1. How many times the loop will iterate? The absolute value. Both are giving both fa functions and del f of a. Rather x is float and a is also float. F is float, a is also float. So what is this FBS function does? The FBS function takes a single argument in double and returns the absolute value of that number that is also in double, and find the absolute value of an integer or float. You can explicitly convert the number to double. So if FBS function will basically takes a single argument as double and returns the absolute value that is also in a form of a double. I hope you know what is the meaning of this absolute value. Coming back to the program once again. So when this x minus a, that means current approximation value and the previous approximation value difference, absolute difference is greater than e. E is already taken by us as an input. Say E is taken as a 0.0001. So when this two difference is more than 0.0001, then it will iterate once again. When this will iterate, when this will give us more than 0.001, so it will again iterate. If it is not more than this, so it will stop over there and you will get the result of x. So let me execute the program. So I'm considering the accuracy is 0.0001 and the initial value I am considering as per the assignment, my root value is 2.279. So I may consider the root lies between 2 and 3. If you put the intermediate value, if you put the value 2 over here, how much you will get? 2 cube, that is 8, minus 6, minus 5. So that is 8 minus 11, it is minus 3, right? When the value is 3, 27 minus 14. So it is something positive, plus 13 probably. So definitely your root lies between 2 and 3. So I consider the initial value as 2. Look, in loop it gets printed because I have given to track how many times the loop iterates. That means how many times this approximation function calculates, and the result comes 2.279019. So if you check the result in the assignment, yes, it is 2.279. Fine. Once again, I am executing the program, same program, with the value, with the different initial value, that is 3. Because I told in the theorem that I may consider the initial value A or B, any one. So previous execution, considering the initial value is A. Now, accuracy I am considering 0.0001. Fine, 0001, that is the accuracy I am considering. The initial value now I am considering 3. Still I will get the result. Look, 2.279. So I hope you understood this concept and this program. Now try to implement this 3. First one is trapezoidal, second one is Simpson 1/3, and the third one is Newton-Raphson from these 2 assignments. Thank you. Thank you so much.